There's a supermassive black hole at the center of every galaxy.
Yeah, ultimate of no escape, the ultimate prison. You're going to get squashed to an infinitely dense.
The James Webb Space Telescope, humanity's most powerful window into the universe, has just returned data so astonishing that it has left the scientific community reeling and the world frozen in collective awe. It didn't discover a supernova, nor a distant planet similar to Earth, nor did it detect signals from an alien civilization. What it uncovered was something far more elusive, something that challenges our deepest assumptions about the universe itself. A structure so ancient, so pristine, and so contrary to the established understanding of cosmic evolution that it is forcing cosmologists, astrophysicists, and theoretical physicists to rethink everything from the origins of the universe to the very laws of physics. Before we start, smash the like and subscribe buttons for more updates. The discovery centers on a galaxy cluster, or what initially appeared to be one, located at a redshift far beyond what even the boldest models of early cosmic formation could have predicted. This cluster, now designated JWG17A, sits at an estimated redshift of Z20, meaning it formed just a few hundred million years after the Big Bang. Prior to this, scientists believed that such complex and massive galactic structures could only begin forming about 1 billion years after the universe's inception. Yet here Webb was, capturing intricate spirals, signs of dust, and even mature star populations in galaxies that simply should not exist that early. The structure seemed old, far too old, and somehow impossibly advanced. Webb's instruments, particularly its near-infrared camera NIRCam and mid-infrared instrument MIRI, were critical in analyzing the light signatures of these ancient formations. These tools allowed scientists to peel back the veil of interstellar dust and cosmic time, revealing details with a clarity never before achieved. What they found in the spectral data contradicted decades of accepted cosmological theory. The elements present in these galaxies suggested multiple generations of star formation, meaning entire cycles of stellar birth, death, and rebirth had occurred within just a few hundred million years of the Big Bang. That shouldn't be possible. There simply wasn't enough time for stars to form, explode as supernovae, disperse heavy elements, and then birth a second or third generation of stars. And yet it was all there, laid bare by the Webb telescope's unprecedented clarity and depth. The implications were immediate and chilling. If these galaxies are as old and evolved as they appear, the universe may be far older than we thought, or it may have evolved under physical laws that we do not yet understand. Either scenario represents a cataclysmic shift in our comprehension of cosmic history. It shakes the foundation of the lambda cold dark matter model, which has been the prevailing cosmological framework for decades. According to that model, matter clumped together gradually after the Big Bang, and it took hundreds of millions of years for the first stars and galaxies to form. Webb's latest images tell a different story, one of abrupt, explosive complexity emerging out of what should have been primordial simplicity. The ripple effects of this discovery extend far beyond the confines of astrophysics. They touch on metaphysics, philosophy, and our most intimate assumptions about existence itself. Humanity has always looked up at the stars for context, for a sense of our place in the grand tapestry of creation. To find that tapestry rewoven, its threads tied in ways we never imagined, is nothing short of existential. Scientists are now scrambling to reassess everything from the age of the universe to the role of dark matter and dark energy, and even the nature of time itself. The very timeline of cosmic evolution may be flawed. We may not be looking at the first galaxies, but at something else entirely. Something possibly older than time as we understand it. This isn't just a scientific puzzle, it's a paradigm shift. It's as though humanity has been reading the first chapter of a book and thought it understood the story, only to discover there were 20 prologues we missed. And now we're being forced to reread everything with new eyes. The discovery of JWG17 might very well be one of those moments in history akin to Copernicus suggesting the Earth orbits the Sun, or Einstein redefining gravity. Except this time, it's not just one aspect of physics or astronomy that is being rewritten, it's potentially the whole narrative. Adding to the enigma is the anomalous behavior of light around the newly observed cluster. Webb detected subtle gravitational lensing patterns that suggested not just the presence of massive quantities of dark matter, but perhaps an unknown form of matter entirely, something even stranger than dark matter itself. The way light bends around this cluster implies that the gravitational field is behaving irregularly, as though the mass is distributed in configurations we don't recognize. Some theorists have proposed that we might be glimpsing higher dimensional structures, objects whose true nature is hidden from our limited three-dimensional perspective. If this proves true, then JWG-17A may not just be a relic of the early universe, but a bridge to understanding phenomena like wormholes, the fabric of space-time, or even the long-theorized multiverse. It may be a cosmic fossil from a prior iteration of our universe, evidence of a cyclic cosmology where universes are born, die, and are reborn through cosmic epochs. This would explain its age-defying characteristics and the seemingly impossible complexity of its structure. Such a notion, though speculative, is gaining traction among theorists who have long suspected that the Big Bang might not have been a singular, unrepeatable event, but part of a grander, infinite cycle of creation. Further complicating matters is the strange radiation signature emitted from one of the central galaxies in the cluster. Unlike the familiar electromagnetic signatures from quasars or star-forming regions, this signal displayed a sharp, narrow band of frequencies that pulsed rhythmically over several hours, then stopped. It wasn't a communication, at least not in any decipherable way, but it also didn't align with any known natural phenomenon. While the idea of alien intelligence immediately enters the popular imagination, most scientists remain cautiously skeptical. Yet the regularity and sudden cessation of the signal is a mystery that refuses to go away. Perhaps the most chilling implication is not just that we may have been wrong about the early universe, but that we've been missing something crucial, something hidden in plain sight. This isn't just about distant galaxies anymore. It's about the framework of knowledge we've built to explain the cosmos. Webb has effectively turned the cosmos into a hall of mirrors, showing us that the reflections we once trusted are distorted by assumptions that no longer hold up under scrutiny. The known universe feels suddenly unfamiliar. The familiar markers of time, scale, distance, and progression seem off-kilter. It's as if the cosmic clock was ticking all along, but to a rhythm we never heard until now. With each image it sends back, the James Webb Space Telescope is not just mapping the universe, it is unraveling it. And in the process, it's unraveling us. What do we do when the past becomes uncertain, when the very notion of a beginning begins to blur? The discovery of JWG-17A doesn't just hint at an older, more complex universe, it hints at our profound ignorance of it. It demands new physics, new mathematics, and a new humility. The scientists poring over the data are doing so with a mixture of excitement and unease. It's a thrilling moment, but also a daunting one. Every new spectral analysis opens another door, and behind it lies a question we didn't think to ask. Theoretical models are being rewritten in real time. Simulations, once considered reliable, are being tossed aside. The blackboards of university halls are cluttered with equations that try to account for a universe that seems more like a grand illusion than a predictable mechanism. Some voices are quietly suggesting a return to radical ideas, cosmic inflation models with exotic scalar fields, pre-Big Bang scenarios involving quantum loops, or even frameworks that account for the universe as a holographic projection from a higher dimensional realm. Ideas that once lived on the fringe of physics are being invited back to the table, not out of desperation, but out of necessity. The data demands it. The James Webb Space Telescope wasn't supposed to do this. It was supposed to refine our understanding, to add clarity to our models. Instead, it has shattered the lens through which we view the cosmos. It has thrown open the curtain not to reveal the answers, but to show us how little we understood the questions, and this is only the beginning. JWG-17A is not the end of the story. It's the prologue to a new cosmic narrative, one written in light older than our oldest ideas. The freezing silence that followed the announcement of this discovery wasn't just awe. It was the collective realization that the universe had just spoken in a voice no one expected. And now, as that voice echoes across the halls of science, humanity must find a new language to understand what it's saying. Webb has done what few tools in human history have achieved. It has forced us to see reality anew. Its mirror has shown us not just distant galaxies, but the mirror of our assumptions, our models, our confidence. And that mirror has cracked. In its reflections, we see not chaos, but the invitation to deeper truth. One that will take generations to fully grasp. One that may ultimately redefine what it means to be a thinking species in a cosmos vaster, older, and stranger than we ever dreamed. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on what the James Webb just found out there? We want to hear from you. Thank you for watching, and see you next time.